Thank you very much again. Very honored to be here. I am Alejandro Mercado, currently living in Mexico City, and well, I am going to talk about a little bit about GitOps and observability. Let me share my presentation, my deck. So the name of my talk is Observability, the key to unlocking GitOps. So this is a little bit about me. I am a dev now doing DevOps, living in Mexico City. Also proud member of the DevOps Institute as ambassador for Mexico, GitLab Hero, and Dev Network Advisory board member. So there's my LinkedIn if you wish to connect, be my guest. So, well, I would like to start with this slide to mention with this warning that this talk is an holistic approach, a reference by reference to the whole. So I don't just want to talk about some specific topic, technical issue, pretty deep. If not, I would like to talk about the to see the forest instead of the whole tree or just one tree. So I would like to start with observability. So observability is, well, there is not a single definition about observability, but observability is a management strategy focused on keeping the more relevant and important and core issues at or near to the top of on an operation process flow. The term is also used to describe software processes that facilitate the separation of critical information from routine information. So seems like a little academic, the definition. So maybe when we contrast observability versus monitoring, we have a better understanding of what observability is. But I would like to, or some companies like to explain observability with these three pillars. Metrics, traces, and logs are the three pillars of observability. So you can think of observability in these three components. It's like the secret sauce. When you have this data, you can be proactive and you can observe your systems. So well, it can also refer to the extraction and processing of critical information at the highest level architecture of operation systems. So as I said, when we put in contrast with monitoring, when we talk about monitoring, maybe you have been there diving in a logs ocean, so tons of lines of that it takes a while to get real and important information about what is going on with the system. So that's why we have these new tools. So and actually in most cases when we talk about monitoring, it's because we are doing a post-mortem analysis. So this is the main difference between observability. Observability is to be proactive, is to have this information to avoid that the system crashes or to have some problems and even then the user report the issue or the problem, we already know about it because we have this observability running end to end. So monitoring tools passively gather information, most of which turns out to be insignificant or we don't get the real important information. So this can run operations, personnel, and even AI tools in data. So versus observability that actively gathers data to focus on what's relevant, such as the factors that drive operations, decisions, and actions. So in this side is observability and why it is important, because we are going to see proactively our systems. These new terms is not that new, but a lot of companies are adopting GitOps because it represents some advantages. So GitOps in a pretty brief definition, GitOps uses Git repositories as a single source of truth to deliver infrastructure as code. So single source of truth is the key definition. So you can see this image. This is GitOps in a nutshell. We are going to have our desired state in a couple of manifests, Well, I have to say that these GitOps tools add a control plane to Kubernetes. So we have this repo, this Git repo. It can be GitHub, GitLab, any repo, any repository that you have, it doesn't matter. But you have the manifest in this repo. This manifest is the source of truth for declarative code. So it's going to do a reconciliation with when you are committing and releasing your code. This is the CI/CD pipeline. So you are running a series of stacks, resulting in the update of the runtime environment to match the source. So if there is a discrepancy or a difference between the desired state and the actual state of the system, it's going to do the reconciliation loop. So submitted code checks the CI process, while the CD process checks and applies requirements for things like security, infrastructure as code, or any other boundaries set for the application framework. All changes to code are tracked, making update easy while also providing version control should a rollback be needed. So, well, this is GitOps plus observability. I would like to recommend to take a look at this image. So you have the desired state and the current state, and in the middle you have the reconciliation loop. So I think that this is the key or the medullary stone of GitOps. So we observe, and if there is a difference between these two states, we adjust. So that is why observability is key for GitOps. We can do GitOps without observability. So why GitOps is important and why companies are adopting GitOps, because we have several advantages from other release management strategies. We have improved security and compliance, increased collaboration and productivity, decreased manual oversight, faster deployments, and increased reliability. And by the way, there is this site that I totally recommend to take a look. You can enter to open https opengitops.dev. So you have this initiative that it sets like the principles of what is OpenGitOps. So OpenGitOps is a set of open source standards, best practices, and community-focused education to help organizations adopt a structure, standardizes, approach to implementing GitOps. So I highly recommend to take a look of this site. So it's not about the implementation or tooling. It's like a neutral vendor site. So the principles of GitOps, this principle I have to say are extracted from the site. The principle of GitOps is that it's declarative, so you don't do imperative command lines. So it's based on manifest files, that, like I said on a previous slide. So it's declarative. A system managed by GitOps must have its desired state expressed declarative. Is YAML, YAML is nowadays everywhere. Is versioned and immutable. That means that the desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. So it's similar, like, when developers make commits and they have this versioning and can do rollbacks. It's pretty like the same. That's why it is GitOps. It's pulled automatically, so it's pulled because there are another paradigms that are pushed. In this case, GitOps is pulled automatically. So the software agents automatically pull the desired state declaration from the source. So it pulls the desired state, do the reconciliation loops with the actual states, and if there is something, if there is a mismatch, it's going to do the healing. So it's continually reconciled. So software agents continually observe actual system state and attempt to apply the desired state. So that's why you can, that's the way that you can have a high availability system, and it's pretty easy to maintain, even if you have a lot of, if you have 100 of pods and your Kubernetes cluster is too big. This tool even have some nice graphical user interfaces that you can handle the state and see if something is wrong. You can apply the reconciliation. So the demo, there is no show me the code. No, is what developers say. So there is a lot of tools that are applying the GitOps paradigm, like FluxCD, Werf, Harness, Jenkins, CodeFresh, that actually uses Argo CD, Wave. So well, in particular, I'm going to do the demo in Argo CD. So Argo CD is a declarative GitOps continuous delivery tool for Kubernetes. So remember, it's a control plane running on Kubernetes. It's another control plane running on Kubernetes, so we can handle the releases. So at this point, I'm going to show the site. So there is a pretty cool training in. If you go to codefresh.io, you can find some training. So I will highly recommend to take this training, because our folks of CodeFresh already did the setup, so it's already there. It's pretty easy just to follow the instruction that, as you can see in my browser, we have all the instructions just to follow. So I will just show one of the lessons that is just to show So it takes a little bit to prepare the environment. Okay, so we have the environment. So as I said, go to this address. It's learning.codefresh.io. So it's pretty handy, pretty useful. You can learn about Argo CD from GitOps fundamentals to some more advanced topics. So it's pretty cool because we as I said, we just have to follow the instructions. So the first task is to fork this repository that we have on github.com. So we have already, I can show, I have my this is the so as you can see, Argo CD is already installed, and you can handle GitOps with the command line interface. I mean, writing commands, but you also have this nice Argo CD UI. So you can see it's like pretty nice, pretty useful interface that you can see what is going on with your Kubernetes clusters, and if something is wrong, you are going to see here in red if some pod is failing, or if we lose communication with you are going to visually see immediately. And of course, you can do something to try to repair, or to do a rollback, or to do something. So we are going to do a new app. The application name is whatever you want, demo. The project is default. The repository URL is the certification examples. I think it's without the Git. And the path is simple app. The cluster is the default that we have. You must need a Kubernetes cluster already installed. That, thanks to our faults from Codefresh, we already have there. And the namespace, we can set up the default. So you can leave these other arguments empty for now. So that's it. You can click on create. So at this moment, we are going to have our first application running on Kubernetes and based on GitOps. So you can see the application is out of sync. If you see the yellow indicate that it's out of sync. So you can sync the manually, but the idea is that you are not going to wake up every morning to sync all the Kubernetes clusters. So it can be set up in automatically, but it's for demo purposes. I just wanted to sync it by clicking this button to synchronize. Remember the desired state with the actual state. So if there is a difference, a discrepancy between the two states, it's going to throw an error. So it's processing. Of course, in the simple app, you can take a look of the manifest, because maybe you are wondering about, well, what is going on in the deployment is using this manifest. Of course, the deployment is pretty simple. It's just an application, a trivial Go web, an application in Go, in the Go programming language. So we just have one replica. Maybe if I change this state and do the synchronization again, it's going to throw an error, because now I am telling that the desired state is 2 or 5 or 12. So this is just it's a pretty simple deployment file, YAML. So you have this container that is running a pretty simple application, and the services. The other YAML is just exposing the application in the port 8080. So nothing too complex, but I think it's pretty illustrative. So it takes a little bit to get the synchronization. But as you can see in this learning environment, we also have the shell. So a lot of these activities or tasks, we can also do that on the, I mean, in line by line. I mean, entering the commands. So it totally depends on what you prefer. So when you have this nice interface, maybe you want to take advantage of that. So I just want to see if the deployment is already done, because I think it's a little bit slow. I don't know if it's my connection. I have my deployment, my simple deployment, but it's not ready. The pod is not available yet. So we have to wait to the. As you can see, the GUI interface is pretty nice. I think it's pretty handy. If you have some problem, you are going to have this health status. You can see in this side menu bar. So well, the first is the sync status. It's unknown, synced when it's green, and out of sync. Well, in this case, the status is processing the synchronization. But as you can see here in the health status, if something is going wrong, you are going to see it pretty visually. It's going to put in red the frame. So maybe you can do the rollback, and you can do the rollback here in the Argo CD user interface or in the command line. It's totally up to you. Of course, I didn't show that, but you have to install the Argo CD in the Kubernetes cluster, and an easy way to install Argo CD is with the Helm package manager. So well, I am going to go back to my slides, waiting to have this already synchronized, but well, it's just to give an idea of what we are talking about. So going back to my presentation, if we can get any conclusion of this, is, well, there is a lot of operations. There is the evolution of operations, and it's quite a bit, a lot operations. No, so this is kind of fun because we started with ops, following DevOps, DevSecOps, DevSecMLOps, Triceratops. That this is a joke, but there is another ops, no, data ops, GitOps, of course, AI ops, no ops, and you name it, ops. So it's evolving. I mean, but for sure, GitOps is an important thing. So you can see that a lot of companies are adopting the GitOps way to do their releases and to manage our Kubernetes clusters. So definitely GitOps is currently in the stage of its germination. I mean, it's a starting. It's going to grow. It's going to grow for sure. So you can see the numbers. So totally a good investment of your time if you are already doing DevOps. The recommendation is just to learn another tool. I mean, it can be tough because you already handle a lot of tools, but GitOps is going to be part of. Sometimes people ask about if this is going to replace DevOps. It's not a replacement, it's a companion. GitOps is neither better nor worse than DevOps. It's not the correct approach. GitOps without DevOps does not have a future. So you need DevOps to do GitOps. The scope needs to be changed and directed at further investigation and how the approach can aid DevOps. So, well, DevOps is just a cultural thing. Also, GitOps is part of that. So it's unlikely that GitOps will become something bigger than DevOps. It's not. It's complement DevOps. I would like to say. So if you take something of this brief talk, the four takeaways will be: you cannot do GitOps without observability. Observability is important to have all the time, to observe all the time our systems. And Git is the single source of truth for the system intended state, while observability provides a single source of truth for the system actual state. The third one is internal observability, allows the GitOps controller to identify configuration drift. External observability allows operation staff and other systems to identify changes in the cluster. So, cloud native observability, as I said, is a new skill and task you must add to your DevOps teams for sure. So, thank you very much. This is all for me. So, thank you very much. And I am going to be around here. This is my Twitter. If you want to contact me, be my guest. So, thank you very much. Bye bye.